Hi, so in this video, we're still continuing chapter 9, universal law of gravity. And in this video, we're going to talk about inverse square law. That's the part of the universal law of gravity. Again, I'm going to move into the whiteboard. So share the screen here. Okay, chapter 9. Gravity. Let's review the universal law of gravity. Gravity. That says any objects feels the gravitational force due to another object by this is the how much they're going to feel the gravitational force, and where this big G is the universal gravitational constant, 6.67 times 10 to the minus 11 Newton meter squared kilogram squared. Okay, so this is the universal law of gravity. And you see that, so the universal law of gravity says that gravitational force between the two objects depends on the mass of the two objects and a constant value. And it also depends on the distance between them by 1 over d squared. Okay, 1 over d squared, this part. This 1 over d squared. So gravitational force, Fg, or Fg that we've been talking about, depends on 1 over d squared. So whenever you have a 1 over something square, that's called inverse square law. It's following the inverse square. Which means that as farther away, if you move farther and farther away, the force, the intensity of the force decreases by, not by, so let's say if I move twice the distance away, then it doesn't decrease by 1/2, it decreases by 1/4. If I move 3 times the distance away, the intensity of a gravitational force decreases by not 1/3, but 1/9. So it decreases by 1 over d squared. So example, twice the distance. Force is 1/4 weaker. 3 times. And the force is 1/9 weaker. I can plot this in a graph. Let's see. So let's say here. Remember the gravitational force. So let's say I could be here is the distance. This is going to be the d, right? The distance between center of the earth to where you are. Then it's starting from on the surface of the earth. On the surface of the earth, you have a gravitational force about, let's say, this much. This is going to be the Fg, or I should say Fg, right? That's how much force you have. It could be 100 Newton, 200 Newton, or something. But if you follow this inverse square law, right? 1 over d squared. If I move a little bit farther away, this gravitational force decreases by 1 over d squared. So it doesn't go like this, but it goes, if I move, let's say, if I move, well, we don't know how much before. So like if it was here, let's say if I move this much, you can see that this, as you go farther away from the surface of the Earth, the intensity of a gravitational force decreases by, it goes by 1 over d squared. So farther away, let's say if this is starting from 0, then about here, this is the 0, right? And then this is going to be twice over RE. Then this was the initial value. This is the initial. This is going to be 1/4 of this one. So let's say this was the, I don't know, some kind of a force. It could be 100 Newton or something. If you go up, so this is the center of the Earth, right? So the Earth is looking like this. This is the Earth here. And this is the center of the Earth. If you go up above the Earth, same distance of the radius away, then intensity of the gravitational force becomes 1/4 of where you were on the surface of the Earth. Erase it. Can't see it so good. Green. 1/4. And then if you go 3 times more, it goes by 1/9. Let's show you, I'm going to show you this is what I'm going to show you. Okay. Okay, so you see that here is the same diagram I'm drawing here. This is 0 when the center of the Earth. And then when you're standing on the surface of the Earth, the distance between you and the Earth is going to be the radius of the Earth, right? And let's say at that time, your gravitational force is this much over here on the top. I don't know if, do you see my cursor? I hope you see my cursor. Then as you go twice the distance, so you go up in, from Earth, you go to the radius, one radius up in a space, then your gravitational force decreases to not 1/2, but decreases to 1/4. If you go 3 times the distance, it decreases by 1/9. So the gravitational force, the intensity of a gravitational force decreases by 1 over d squared, and that's what we call the inverse square law. It decreases, intensity decreases by 1 over d squared. Notice that though, I say the one radius of Earth radius is large, right? We say 6.3 times 10 to the 6 meter. So you go up in a space from Earth, surface of the Earth, you go up in a space that's 6.3 times 10 to the 6 meter above you. You still have gravity. On the other hand, you still have a gravitational force. That's 1/4. So let's say you weigh, what is it, 100, let's do 140 pounds, 120 pounds. Then you go up all the way up in a space that's really far, high up in a space. You should still weigh, if you were 120 pounds on Earth, you should still weigh 1/4, so 30 pounds. 30 pounds. Let's say if you used to weigh 160 on the surface of the Earth, you will weigh 40 pounds. That's really, really high up in the sky, space. Just notice that, okay? You still have a gravitational force that's significant, but not as bad as not it's not one half. It decreases, like 1/d². But just notice that, okay? This is another good pictorial explanation of the inverse square law, I think. So imagine you have a can of spray and then you spray it, right? Then let's say you go a distance away. This spray will cover this 1 unit sheet of a paper. And you get a uniform colors, whatever the saturation you get from the can of a spray. Let's say you have to go twice of the distance from the can. Now you see that in order to cover the whole entire the spray, not just only the same size of the sheet you need to now have not twice. Now you need to have 4 times more to cover the spray. And you see that each sheet has 1/4 of intensity, saturation of the color. So the intensity of the color also goes down by 1/4 when you're twice the distance away. When you go 1/3, when you go 3 times the distance away, it's not that you need 3 sheets. Now you need 9 more sheets to cover the whole spray, and the intensity or the saturation decreases by 1/9. And you go 4 times the distance, then it becomes 1/16, right? So you see how the intensity decreases as you go farther and farther away. It follows the 1/d². So forces comes out from the center of the object in a radially uniformly everywhere. But then you go farther away, the intensity of the force decreases by 1/d². So this intensity force you can also apply to like a radiation too. Let's say you have a TV that has the radiation. If you're watching this much, the screen, just step back. Step back. So if I go like this much, right? If I go back this much, twice the distance, intensity will decrease by 1/4. So just stepping back a little bit makes a big difference in the intensity. So you don't get as much radiation. So stepping not so close, but putting away really decreases the intensity by 1/d². Okay, so this is the end of the inverse square law. It's a quick one. And in the next video, I'm going to talk about weight and weightlessness.